Good afternoon. This is Praveen from PG Department of Computer Science. Today I am going to tell about theory of computation. In this introduction part, so what is computation? What is meant by computation? Computation is nothing but it is a executing on algorithm. It involves taking the what are the inputs and performing the required operation on it. So we have a whatever that input is given, that one they will be processed as a function that will be give the result as the f of x, that is the output. Computation is a sequential of steps. The particular steps is performed by the computer. So next one, what is the formal language? So formal language is nothing but it is a language. We have a set of valid things. What is set of valid things means? That is a empty set, whatever that finite or infinite. Finite is countable, infinite is that is uncountable. We have using of a language with L of M, that is a language, that is a mission. Language is defined by the mission M, that is L of M. So that we can also use that L of G, that is a language is defined by the context-free grammar, that is L of G. There are two notations, so that is specifying the formal language. One is called as grammar or regular expression, that is generative approach. Another one is the automation, that is called as a recognition approach. So next, what is theory computation? Theory of computation is nothing but it is it is the branch of the computer science with the mathematical computations. So they can have the solve the problems using of mathematical problems. So that is we have using the algorithms. In the computer terms, we can use that algorithm is nothing but it is a sequence steps. So the field is this field is divided into three major parts. One is called as automata theory. Another one is the computability theory, and another one is we have a computational complexity theory. So next one, what is automata theory? So automata theory is a study of abstract mission, that is a mathematical missions or systems. So these abstract missions also called as the automata. So automata, which means that something what we are doing is something by itself. So that is a theory that is closely related to the formal languages. So we have it is classified by the class of the formal language. They are able to recognize that one. So here we have automation is nothing but it is finite, that is a countable representation of the formal language that may be an infinite set, that is a uncountable set. So next one, examples of abstract missions is nothing but Turing mission, another is the finite automata. So next, why we have switching over to circuits to formal languages, that is the finite state automation means. So we have a switching circuit consists of a set of logical gates, that is zeros and ones, that is a true or false. So we have any of the two conditions, that is called as a 0 and 1, that is a true or false. So they can have using of the voltages, that is electronic circuits. They can have the corresponding values of 0 or 1. So they can have the stable and others adjustable to control the computer. The computer is a finite state of system. So here we have in this diagram given that one, we have flip switch up, that is on, another flip switch down, that is a off. So next one is the alphabets in automata. What is alphabet? It is a countable, non-empty set of symbols that is denoted by the summation symbol. That is we have here one example given that one, summation equal to a comma b, that is two symbols, that is a and b. Another example is given that one, set of numbers, that is 0, 1, 2 is given this example. They can have the three symbols with the that is 0, 1, 2. So next, strings with example. What is strings? A string or word, it is a finite, that is countable sequence of symbols over the from lang, that is the input symbols. So the group of characters also referred as a string. For example, A, comma B, comma C as the symbols that can be formed as the A, B, C, B. So that is a string. Another one is we have a given that language, they can have the input symbols A, comma B. They will be formed as A, B, A, B, A, B, 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 and A, B, B, B. So like that strings over the alphabet as the given for that. Next, another example is given that numbers, that is 0, 1, 1, 1, 0, 0 and 0, 1, 1, 0. So are the strings over the input symbols 0, comma 1. So next one, what are the operations on these strings? Operations are string of nothing but we want to find out the length of the string and the empty or null string and the reverse of the string, concatenation of string and power of an alphabet, substring and reversal of string, cleaning plus closure. So what are the applications of the computations? So we have analysis of algorithm, compiler design, complexity theory, cryptography and robotics, circuit design, artificial intelligence, knowledge engineering. So next, what is theory of computation? Again, I am telling that what is theory of computation is nothing but it is a branch of computer science with the mathematical. It deals with how efficiently the problem can be solved using of the computation, that is we are using the algorithm, that is the basic steps of explanation of the problem. Here where it can be used, theory of computation. So this can be used in text processing and compilers and programming languages, artificial intelligence, genetic programming languages, neural networks, robotics. So here some of the models is given for that one. They can have the different languages and automation and grammar and aggregation. In this diagram, so we have recursively enumerable languages that can be using of automation, that is called as a Turing machine. They can have the grammar is unrestricted, that is BAA, that will gives the A, that is undefined for that one. Next, second one is the context sensitive languages. So the particular language is linear bounded automation. The particular linear means it is a sequential of that is the states. So they can be using of context sensitive grammar and they can have the exponential. So next one, third one is the context free languages. That is we are going to use that push down stack. So they can have using of context free grammar. So they can have the polynomial. Here the another model is given for one side is grammars, another side is automata. So that grammar is also called as generators and automata acceptors. They can have the some of the subsets is given for that one. In this first regular grammar, they can have the preset is context free grammar and the context sensitive grammar. Another one is the recursively enumerable. In this part, there is a finite automata, push down automata, linear automata and Turing machine. So here the one of the hierarchy, Gomez-Craig hierarchy is given for that one. This includes some of the problems in the word, that is say we have classified into some of the classes, that is say type 0 to type 3. So we have a type 0 all languages is a subset of recursively enumerable languages, that is type 0. Another one is the context sensitive languages, that is type 1. So they can have the subset of context free language, that is the type 2. And another one is the type 3, that is the regular languages. Here we have in this table that will be given that type 3 is the smallest class, type 0 is the biggest class. Here we have comparatively given that row wise, that is a language, automata and grammar. In the type 3 we are going to use that language is called as a regular and automata is finite automata and regular grammar. In the type 2 context free language and we are going to use that push down automata and context free grammar can be used. In the type 1 context sensitive language and they can have the using of automata is linear bounded automata and context sensitive grammar. So in the type 0 recursively enumerable and the Turing machine can be used, that is a unrestricted form. See here language. What is language? Language is nothing but it is a set of strings that is defined by the over alphabet. That is we have a input symbols. For example, let input symbols A comma B. Then we have a formation of, that is a language of 0 union language of 1 language of 2. That is the input alphabet. That is a set of all strings. That is a combining of the more than one strings. That is a universal language. For example, we are taking the A B. That is first you have a empty and A B A B B A or B B. Like that we have a formation of other. For example, another example is called that one language square. That is language 1 into language 1. That is using of concatenation A comma B and dot A comma B. That is we have a formation of A B B B like that. So it is a subset of input closure. That is a L is a subset of language is a subset of the input closure. Here language is nothing but is a collection of strings that must be a subset of language. That is we have language closure where language is a universal language. That is we have L equal to A B star means we have producing that one A B like that is going off A B like that is going off that one. So here types of languages. We have different types of languages. One is called as finite language, infinite language, and regular language, and determinate finite control free language, and control free language, and context sensitive language, recursive language, and recursive enumerable language. So next one, what is the relation between the symbols and alphabet and string and language? Here, for example, one language is developed by the using of depending on the tokens. Tokens is nothing but it is the smallest individual units of the programming language. That is we have a variables, identifiers, and constants, all those things. So that is formation of using of character set. Character set is nothing but it is a alphabets, numbers, special characters, and white space characters. So that is built up on using of the character. That is one by one. Character is a group of character set. That will be tokens. That will be language. Like that in this part of English grammar, the symbols. That is the formation of symbols is nothing but alphabets. Alphabets makes as a string more than one alphabet. That will be formation of language. So here types of automata. In this diagram, that is we have a chart. We have automata is classified into the 5 different types of divisions. One is called finite automata, another one is the push-down automata, another one is the linear bounded automata, another one is the halting Turing machine, another one is the Turing machine. So again, finite automata is classified into 2 things. One is called as acceptors and the transducer. So acceptors is classified into 2 types. One is called as determinate finite automata, another one is the non-determinate finite automata. So in this non-determinate finite automata, that will be classified into 2 types. One is called as without null moves and with null moves. So in this another part, we have finite automata transducer. Transducer, they can have the 2 types. That is called as Moore mission. Another one is the Mealy mission. So next one is the push-down automata is classified into 2 types. One is called as the deterministic push-down automata. Another one is the non-deterministic push-down automata. So next one, linear bounded automata is divided into 2 types. That is DLBA and NLDBA. DLBA nothing but determinate linear bounded automata. Another one is the non-determinate linear bounded automata. So next one is the halting Turing machine. So in this part, another one is the 5th one. Turing machine is classified into 2 types. One is the determinate Turing machine. Another one is the non-determinate Turing machine. So now we are going to go to the finite automata. What is finite automata? In this part, finite automata describes the or represent the regular languages. In the finite automata is a 2 types. One is called as acceptor, another is the transducer. Acceptor is nothing but we can accept the language or string, accept the string or rejects the given string. So transducer, it produces the output. It produces the output string for a given input. For example, here one word is given that one, a particular language acceptor is accepted or not. That is, acceptor going to recognize the whether word is belongs to the language or not. In this part, we have a transducer. It produces the one word is given, that one they will be processed and giving the another word. That is a transducer produce the W2, that is a word 2 if a given input is word 1. So one word is given for that one, another word. So next one, what is the example of that one? Means complement of binary number is, for example, we are given that input, that is a 1 0 1 0 0. What is the output for this? 0 1 0 1 1. So next one, in this part, finite acceptors. In the finite acceptor, it is a 5 tuples that will be represented here. One is called as Q, another one is the Q is nothing but set of finite number of states. Second one is the input, set of input symbols, that is given that one. Then another one is the transition function. Another one is the initial state, another one the final state. These are the 5. So another part of the DFA and NFA. Determinate finite automata, they can have the transition function is, that is we have the number of states into, that is a number of input symbol that gives the number of states. Next one is the non-determinate finite automata. They can have the without null moves, another one is the with null moves. Without null moves, they can have that number of states into number of inputs. They can be given as the 2 power of a Q. So with null moves, that is a Q, that is a number of states into input symbols. They can, with the union of null character, they can be given that 2 power of Q. So here the construction. Thank you.